Alright guys, today we have another PlayStation 3 Slim. This console came from a customer after another technician had already tried to repair it. The current condition is GLOD, green light of death. When I power it on, the green light stays on, but there is no display, no boot and no blinking red light. Completely dead system. So let's open it up and see what happened here. PlayStation 3 Slim motherboard here, KTE-001. Okay, the motherboard is out now and immediately I saw a lot of flux around the CPU area. So definitely somebody already tried to reflow this chip using a heat gun. And honestly guys, uncontrolled heat gun work on these KTE boards can create even more problems than the original fault. Especially because these motherboards are multi-layer boards with very sensitive traces under the CPU. Anyway, before doing any diagnostics, I completely cleaned this motherboard using isopropyl alcohol. Because corrosion, dirt and old flux residue can affect measurements and even create leakage between signals. Guys, the motherboard is now fully cleaned. Now let's test the motherboard again and see whether anything changes. Okay, interesting. Now the symptom has changed. Previously, the system was staying on in GLOD condition, but after cleaning it now powers on with a green light and instantly turns off. Now this is actually important. Whenever a motherboard changes symptoms after cleaning, that usually means something electrical is reacting differently. So now I know this board is worth investigating deeper. Now I'm starting diagnostics from the secondary power rails. I'm using my SMD tester and the component tester built into the oscilloscope. I'm checking low ohm resistors, CPU feedback lines and coupling networks around the DC to DC converter section. Let's see what we find. Okay guys, I found something suspicious here. These two resistors are showing abnormal readings while connected to the motherboard. These resistors are connected between the CPU and the DC to DC converter controller section. So first I want to confirm whether the resistors themselves are bad or whether something else in the circuit is affecting the reading, so I removed them from the board. Both resistors were removed, and after measuring them outside the circuit, both were actually perfectly fine. So the resistors are not the problem. That means the signal path itself has an issue. Now I'm going to check continuity between the CPU pin and this feedback line. Okay guys, now this is getting interesting. The signal from the CPU side is disconnected. And look at this, there is no full logic curve showing on the component tester, but a slight curve in straight line. I am measuring impedance to ground on this CPU signal line, and I am getting around 14.97 kilo ohms. That reading does not look normal. So I am going to compare it with another donor KTE-001 motherboard. Alright, on the donor board, the same line measures around 12 ohms to ground. So now everything makes sense. The solder ball connection underneath the CPU is partially disconnected from the motherboard pad, most likely caused by previous heat gun work. This broken connection is interrupting communication between the CPU and the DC to DC converter feedback network. And because of that, the motherboard cannot complete proper power sequencing. So at this point, I'm going to attempt a controlled CPU reflow using my BGA machine, not a heat gun. A proper controlled thermal profile. The purpose here is to see whether the disconnected solder joint reconnects properly. Let's put the board into the machine. Alright guys, the reflow process is complete. Now I am reconnecting 5V standby 112V input and the power switch strip. Let's see what happens. Okay, still the same symptom. Green light and instant shutdown. But now I want to check whether the disconnected line has been restored. Now the continuity between the CPU pin and the coupling resistors is restored correctly. So electrically the connection improved, but the motherboard still does not boot. That means we probably have more serious physical damage underneath the CPU. The solder ball connection underneath the CPU is connected to the motherboard pad, and the signal from the CPU side is connected to the DC to DC converter chip. So let's measure the coupling and feedback resistance readings. As you can see now, they are in a normal range. At this point, the CPU has to come off. Alright guys, the motherboard is back in the BGA machine. I'm now removing the CPU chip completely. And honestly, this is the stage where you finally see the real truth of the repair. Okay, the CPU is removed now. I cleaned all the solder balls from both the motherboard and the CPU substrate, and now under magnification I can clearly see the problem. Look at this corner here. 5 solder balls were not properly bonded to the CPU substrate pads. And over here on the other corner, there's another solder ball with some kind of contamination layer between the solder ball and the CPU pad. That alone can completely interrupt signal integrity. Now let's inspect the motherboard pads. Okay guys, here's another issue. 4 motherboard pads are damaged. So now this officially becomes a microsoldering repair. I'm going to rebuild these pads using ultra thin jumper wire, UV mask, and pad reconstruction techniques. This part needs extreme precision because even tiny height differences can prevent proper BGA contact. Now I'm reballing the CPU chip using fresh solder balls. Everything needs to be perfectly aligned here. Okay guys, the CPU is fully reballed now. Good wetting, clean pads, perfect ball formation because one weak connection can bring the whole system down again. Alright, the damaged pads have now been rebuilt successfully. Both the motherboard and CPU are cleaned again. Now I am placing the CPU back onto the motherboard using the BGA machine. This is the final installation. Alright, the soldering process is complete. Everything looks good under inspection. Now I am reconnecting HDMI cable, 5 volt standby, tool wheel input, and the power strip. Moment of truth guys, let's turn it on. Green light, no shutdown, and there we go guys. Both the CPU chip and the GPU are starting to get hot. I should put a heatsink on them so it doesn't automatically shut down if it gets too hot. We have displayed output on the screen. Thumbs up guys. The motherboard is alive again. After all, the diagnostics, the continuity tracing, the impedance comparison, the reflow, CPU removal, pad reconstruction, and full reballing, this PS3 is finally working again. Absolutely amazing repair. Thanks for watching and I'll see you in the next repair video.